Welcome to the next lecture on data formats. Last time we talked about XML and XML schema as a hierarchical data format and a language that allows us to specify how elements and attributes should look like and what content should they have. Today we are going to talk about two languages which are meant for working with XML data. XPath, which is a query language, which will allow us to query XML documents and get results, and XSLT, which is a data transformation language, which allows us to read an XML document and transform it to another text document. And we'll start with XPath. XPath, short for XML Path Language, as I already mentioned, is a query language which takes an XML document on the input and allows us to query it to get some results. For instance, here we have our data catalog XML document, and we have an example of an XPath query. This example is very simple, and you can read it as you would read a path in a file system. So what this query means is that we'll start from the root, then we'll go to the catalog element. From there, we'll go to the datasets element. From there, we'll go to the dataset element. And from there, we'll go to the title element. And whatever element satisfies this path gets returned. In this example, the following 4 elements are returned as a result of this query. They are the title elements of the datasets. Now, in the second example, we'll have the same. However, we'll add one more step, and that is a text function, which actually returns the text content of an element. So if before we had the 4 title elements, with the text function, we'll have the textual contents of those 4 elements. And in the third example, we'll see that we can also filter the results that we have. And in this case, we simply filter the title elements that we have selected only to those that have an XML lang attribute set to n. So this will result in the 2 texts representing 2 dataset titles in English. This brings us to the specifications of XPath. So once again, XPath has various versions, and all of those are W3C recommendations. What we will see today is mostly XPath 1.0. The most widely implemented version is XPath 2.0, and the most recent version, which gets implemented already in some commercial tools, but starts to make its way into free tools as well, is XPath 3.1. But this is not all, because those specifications actually talk about XPath as the language and what constructs does it have and how it should be processed. But before we can specify that, we actually need a specification of how to interpret the information contained in an XML document. And for that, we have the XML information set recommendation, or shortly XML info set, which basically gives definitions of what pieces of information are present in well-formed XML documents. This specification is created with no particular way of processing the XML document in mind, and therefore to serve XPath and XQuery, which we won't talk about, but it is a superset of XPath. To serve it well, it needs to be expanded, and this is what the XQuery and XPath data model specification actually does. So it builds on XML info set, and it includes support for various things that are then used within the XPath specifications. For instance, in XPath, you can look at the XML document as if it was validated against an XML schema and take some information from the XML schema into consideration when actually reading the XML document. This information may, for instance, contain information about data types of values in the XML document. Because if you recall the last lecture, in pure XML, everything is every value which is not an element is a text. And there are no data types. Data types are introduced in XML schema. So if you want to query your XML document, for instance, for all integers, you need to view the XML document as if it was valid against its XML schema, which actually defines which values are of which data type. So this is what the data model specification talks about. Well, basically, it says that you can view the XML document as a tree, which looks like what's in the picture in the slide. Specifically, let's take a look at our data catalog XML file, and let's take a look at how the XPath data model of that document looks like. The most important thing, which is not visible directly from the XML document, is the document root, which is the actual root of the tree of the XPath data model. It is not visible in the XML document itself. However, when the XML document gets interpreted as an XPath data model, the document root is there, and that is the node that you actually access using the most simple XPath query, the slash. We'll talk about that a little bit later. For this lecture, it is just important to see that the XML document can be viewed as a tree, which has the document root, then the actual root element, which can be only one in XML, and then the children, which some of them are text nodes, some of them are attributes, and some of them are elements. So this brings us to the types of nodes. We will talk about nodes when talking in XPath. And here is a list of node types that you can find in the XPath data model. So we already talked about the document node, or sometimes called a root node. Then there is, of course, a node for XML element, a node for attribute, a node for text, a node for comment, namespace, and processing instruction. We'll mostly work with the document root and the element, attribute, and text nodes here. Right, so let's take a look at some basic XPath examples. I will explain XPath on a set of examples because it seems easier. So as I already mentioned, the most simple XPath query looks like this. It's a simple slash. And this one will actually select the document root node, which is on top of the XML document itself. And each node in XPath has a set of children, and the set of children of the document node is the root element, which is in our case catalog. But here we are just asking for the root node, so result of this simple XPath query is the document node. Let's expand the query with the catalog element here, and result of this query will actually be the XML element catalog with all its content. So the element catalog is the result of the XPath query. At this moment, I would like to say that the result of the query is a set of nodes. In later versions, it's a sequence of nodes. The difference is that set is unordered and the sequence is ordered. In any case, the result of an XPath query is a set of nodes of various types. In this case, the result is a set of one node, which represents the catalog element. Now you may have noticed that we start our query with a slash. So queries which start with a slash are absolute paths because they start in the document node or in the root node. That's not the only way an XPath query can be built. We can also start from a current node, which we will see later. But for now, let's stick with absolute paths, which are those that start in the document node. And this query has two steps in the path. The first step goes to the catalog element, and the second step goes to the datasets element. And the result of this query is the datasets element. As the result of the XPath query is a set of nodes, in this case, when we go from catalog to datasets to dataset, the result will actually contain both dataset elements because we have two, and both satisfy the path that forms the query. In the first version of XPath, there is no specific order between the elements in the result. Now, when we go to the next step, we add a title, and again, result will be, in this case, the two title elements, and we can add something called an access function, which in this case is the text function, which gives us the text content of an element. So here, the result of this XPath function are the two texts, bike sharing in Brno and sdílení kol v Brně, which are the same texts, one in English and one in Czech. Now, another thing we may query for using XPath are attributes. Attributes in XPath start with an @ symbol. So the @ symbol means that we are querying an attribute. So right here, we go from catalog to dataset to title, and then from title to the XML-lang attribute. So the result of this query is a set of two attributes. Each is named XML-lang, each belonging to another element and with a different content. One has the N content and one has the CS content. Now we change the query a bit and we introduce the brackets, which allow us to filter the selected set of results. So here we filter the title elements returned by the query only to those which satisfy the expression inside the brackets. In this case, the expression says there has to be an attribute XML-lang with the value set to N. And this filtered set of title elements is then processed using the text access function. Therefore, the result of this query is the English title of each dataset in our data catalog. Now, I promised when I talked about absolute paths that we will also talk about relative paths. So here we actually will have a relative path, and whenever you are querying using a relative path, you need to know where to start from. When we have absolute paths, we always start from the root of the tree, but when we have relative paths, we need to also have a starting set of nodes from which the path will be evaluated. In this case, the pink bordered element catalog is our start, or the current set of nodes. And from this set of nodes, which contains only the catalog element, we'll go to the title element. We'll filter those which have the XML-lang attribute set to N, and we'll access the text of this node. Therefore, we'll end up with the my catalog title of the catalog. Now, let's take a closer look at the individual steps which comprise the XPath path. So each step so far was an element name or an attribute name. That was, however, a syntactic shortcut. Since you can start in any node of the XPath data model, you do not always have to navigate to the children of the node you are in. So if you use the simple step, which only has an element name, what you are actually doing is that you are saying go to the children of the current node and select all elements which are named, for instance, catalog or datasets. So the two XPath queries in the example are identical. The first query is a syntactic shortcut of the second one. And now you may wonder what is the thing before the double colon. And the thing before the double colon is called an axis. And there are many axes in XPath, And the one that we have got to know so far is the child axis, which means that it will apply the node test, which is the second part of the path, to all the children of the current node. So formally, the XPath path step is formed of the axis specification, then the node test specification, and then optionally a set of predicates, which are the filters in the brackets. If you are using the child axis, that one can be omitted. That's the default one. Now, when we are talking about axes, you may also want to use the asterisk operator, which basically matches all nodes on that axis. So when you see an asterisk with nothing, again, those are all children of the current element. A side note, the children of the current element do not contain attributes or text nodes. Those only contain elements. Right, so let's take a look at another axis, and this one will be descendant. So we'll start, this is again an absolute path, so we'll start in the root, then we'll go to the catalog element, and from there we'll select all descendants, and all descendants filtered to the title elements. So this one will actually select all the title elements in the subtree of the catalog element. Not only the direct children, but also those that are inside the dataset element down there. So this is the descendant axis. And of course, I can use the asterisk operator again and select all elements which are descendants of a catalog element. Now, I may also want to use the attribute axis. And we have seen this before. The shortcut for the attribute axis is the @ symbol. So if I want to select all attributes of all descendants, I can do it in XPath like this. And again, these two queries are identical. And the result of those queries are the attribute nodes of all the descendants of the catalog element. And there are more axes, more interesting ones. For instance, this one shows a preceding sibling selection. So from the document root, we go to the catalog element. From the catalog element, we go to the title element, selecting the two title elements that we have there. And from there, we should go to the preceding sibling title element. Well, which one is that one? Let's take a look. If we go to the left title element, the first one, then this one does not have any preceding sibling. So there, the query won't select anything. If we go to the second title element, then the preceding sibling title element is the first title element. So it will select the first title element and then go to the text node. So this query will actually select the My Catalog text node. Now, another axis we'll talk about is the descendant or self axis, which contains the current node itself and all its descendant elements. And there is again a syntactic shortcut for this, and that's the /. So whenever you see a /, it's a syntactic shortcut for descendant or self. So here we go from the root to the catalog, then descendant or self. So it will contain the catalog and all descendants, and we'll filter that set to the title elements. And we'll end up with the 4 title elements. There are other shortcuts. There is the self node query, which has a shortcut, it's a dot, and a parent node query, which has the $. As a shortcut. Those two are, I presume, well known to you from the file systems, where basically a file system can also be viewed as a tree, and those two steps are also present in each file system. So 1 dot is the current node, and the 2 dots is the parent node. So for instance, if we start in a dataset, the pink bordered node, the self node contains that pink node, and the parent node will point to the red bordered element datasets. For some of the axes, a so-called document order is important because this document order determines which elements are preceding and which elements are following. So we have already seen the preceding sibling axis, and this actually selects those elements with lower document order number. And the document order number is determined by the position of start tags of elements which start the element nodes. So in this case, the document root has 0, the element catalog has 1 because the first start tag is 1, and take a look at the XML representation of the data on the left. Then we have the title element, then another title element, then description, then another description. Then we have the contact point element. Then we go inside, we have the name element, the email element. Then we go outside and we have the data sets element, which is number 8, and so on. So the document order number is determined by the start tags of elements. And this is the overview of all axes available in XPath. So we have seen the self and the preceding sibling and the attribute and the parent and child and descendant axes. And there are also following and following sibling and namespace and ancestor axes. So all those can be used in the axes part of a XPath path step. Let's take a look at some other access functions. So for instance, we can query for the name of the selected element. So this actually goes from the root catalog to the datasets, and then it selects the names of the elements, which in this case is the text datasets. Another function is position. So we may test or get the position of an element in the child sequence of the parent. So here we go to the dataset elements, and one of the dataset elements is first and one of the dataset elements is second. So we get the number 1 and the number 2 here as the result of the position call. Now there is also a syntactic shortcut for testing the position. For instance, we want only the second dataset. So what we would normally do is that we would go to the catalog, to the datasets, then to the dataset, and filter those only to those which have the position equal to 2, which can be shortened to just 2 in the brackets, which means we want the second element in the set, in the sequence. And the next function is the last function, which gives us the position of the last element in the set. And again, we can query or filter a set of result nodes only to the last one, like you can see in the example. There is a handy cheat sheet of all the XPath axes and the most important node tests and functions. So you can take a look at this one as you will be writing your own XPath queries. And before we finish with XPath, let's take a look at some common errors that you may do when writing XPath queries. For instance, here the first query is select car rental companies in Hawaii which offer at least one cabrio. Well, let's take a look at what the XPath query here says. It says we'll go to the rental companies, we'll filter to those which have an element state with textual content Hawaii. We'll go to their offers and we'll go to their cars and we'll filter those cars to the type cabrio. So this actually does not answer the query because when we read the query, we find out that this query returns the car elements, but we weren't asking for cars. We were asking for the rental companies which offer those cars. So the correct query is the one below, which says we'll start in the root, we'll select the rental companies, and the rest goes in the predicate. So we'll filter those rental car companies only to those which are in a state of Hawaii and they have an offering of a car which is of a type cabrio. And this all goes to the predicate. So the result here is the list of rental car companies. Another example is one where the author of the query was not aware of the syntactic sugar, of the syntactic shortcut. So a very popular query starts with the double slash, because that simply selects all the elements named, for instance here, section from the XML document. So if you have an XML document and you know that there are some elements named, for instance, section here, the fastest way of selecting those is the double slash. But you need to know that the double slash is actually a shortcut for the descendant or self axis, and then the node selection function. So this will actually select all the nodes. Then within those nodes, it will select the section elements, and it will select those section elements which are last in their own nodes, which means that this will actually return the last section in each chapter or section, and not the last section in the whole book, as it might seem at first glance. So if you want to return the last section of the whole book, you need to go to all descendants and select the sections and select the last section within descendants, not the last section within each of the nodes selected before. Here is an overview of features present in the next XPath versions, which we didn't talk about properly, but you may come across them and use them if you wish. From XPath 2, one of the features that I actually mentioned is that the result of the XPath 2.0 query is a sequence. So there is an ordering in that sequence. So for instance, if a result is here A, 2, and C, you can access the third node in that result sequence. Also, there is the to operator, which will generate a sequence, for instance, of numbers from 1 to 10. So you may actually generate a sequence from 1 to 10 using the to operator and then access the 7th member of that sequence. There are conditional expressions in XPath 2, so that's the traditional if-then-else construct. And there is also the existential quantifier operator. So you may test that for some, and the $sign stands for a variable. So some title in title, where the second title is the selector of all title children in the dataset element. And you check whether each of those titles satisfies that it has the XML lang attribute set to n. Then there is the for cycle, so you may also do something for each and again variable in a set of nodes, and do something, for instance, return count of distributions. So here, for dataset in all datasets, return count distributions will return the numbers representing count of distributions in particular datasets in the data catalog. And in XPath there are also comments. So the syntax is a bit different than in XML. Note that XPath is actually not an XML language. It has a different syntax, but it is used to query XML. And some of the XPath 3.0 or 3.1 features, one of the interesting ones is the mapping operator with the bang symbol, and that's the exclamation mark. And that will do the following. For each node in the node set, it will call the or do the expression after the bang operator. So here it will count all descendant distributions of each dataset returned by the / dataset, which again results in 1 and 2. There is the string concatenation operator. So if you need to concatenate string, you may do that by the 2 pipes. And there is functions chaining, which is just a syntactic sugar, but it allows you to pass results from one function to another instead of nesting those within parentheses. So here, for instance, we would normally go to a descendant of descendant, which is a data set, we would take the first one and then go to its first title and then do the uppercase transformation on that. Instead, we may be able to say, okay, we'll go to the descendant datasets and their first titles, and we'll pass those to uppercase function using the arrow operator. The second language we will talk about today is XSLT, which stands for XSL transformations. Here is an example of our source document and an XSLT result. So on the left, we have our source, which is an XML document. On the right, we have the result of some XSLT transformation. As you can see, the result here is an HTML document, and it is rendered in the lower right part of the slide. So this is an example of what you would use an XSLT script or style sheet for. And now let's take a look at how does the style sheet look like. Well, an XSLT style sheet is an XML document. So XSLT is an XML language, and as such it has all the usual things like a prologue and a root element and so on. But what is important here is that it provides templates. You can see a template for a catalog, for a data set, and for a text node, and those templates output text. The text may be formatted, for instance, as HTML or as XML document or as an RDF file or basically anything. And in this case, we have a stub of an HTML document here, and in the title place and in the heading place, we have some XSL function, which we'll get to, and that function accesses the input XML document and outputs some part of it as text. So this is an example of how an XSLT style sheet looks like. The interesting part here is that in many places in XSLT, XPath is used. So it's to our advantage that we just talked about XPath. Now, again, we'll start with the specifications overview. XSLT has three main versions. Again, what we will cover in our examples today is mostly version 1.0 or 2.0. The most recent one is 3.0, which again is implemented in some commercial tools and starts to make its way into free tools as well. Before we get to specific examples, let's talk a while about the basic XSLT principles. So the XSLT process has inputs and outputs. The input is one or more XML documents. In our examples, we will always work with one. And the output is one or more text files. Now, the text files we have seen can be, for instance, HTML files, but it can be anything. It can be, for instance, RDF turtle, or it can be a text file. It can be also an XML document again. And the key terms here are XSLT style sheet, which is the XML document which specifies the transformation itself. Then XSLT template, which is the most important part of the XSLT style sheet. Each template matches a part of the input document and produces some output text. And then the XSLT processor, which is the software that takes the input document and takes the XSLT style sheet, runs it, and produces the output. Right, so let's start with an empty XSLT style sheet. So this style sheet has the XML prologue, of course, and then it has the XSL style sheet root element. Here, the version attribute specifies the XSLT version used in that style sheet. Here we have version 2.0. Then we have three basic XML namespaces defined, and we have the XSL output element, which specifies what will be the output of this style sheet. So first attribute, the method, here specifies that the output will be HTML. The other possible values are XHTML, XML. These three basically mean that the XSLT processor makes sure that the output is formatted and that it is a valid document in that language. Then the encoding specifies the encoding used for the output. So for our purposes, it will be UTF-8. And the indent attribute for those formatted outputs like XML, HTML, and so on says that the XSLT processor should output indented document. We'll see that in a moment. It basically means that it is nicely structured. Worth noting is that when you generate other than markup languages, you use the text method, and in that case all the white space from the style sheet gets outputted, and then obviously you cannot indent the output because it is not clear what format it should use. So our example will generate HTML. And let's introduce our first template here. So the template is the XSL template element. It has some attributes, and the content of the XSL template element is what gets outputted. Whatever is not an XSL function gets outputted as is. Whatever is an XSL element, XSL function, gets processed by the XSLT processor. Now, the main template attribute is the match attribute, which contains an XPath expression, which specifies which XML elements from the input document this template should match. So in our case, this template will match the catalog element. And the content of this particular template contains the HTML document stub. So we have our head and our body, and what we will want to generate is the name of the catalog represented. We work with our data catalog example, so we'll want to represent the data catalog as HTML page. So we'll want to fill the title element in the head and the heading element in the body. And we do that using the XSL value of function. It's an XML element with an attribute, the select, which again contains an XPath expression, result of which gets outputted instead of the XSL value of element. So here we actually we are in the catalog node, because that is the node the template matched. So we use relative paths in these XPath expressions, and the relative paths are relative to the node matched by the template. So we are in the catalog node, and we go to the title element, and we filter to the one which has the English text expressed as the n value of the XML lang attribute. One technical note here is that for the values of attributes, or the values of attributes in XML in general, are enclosed in double quotes. Therefore, when you need quotes in the XPath expression, like in this case, in the brackets, we need to enclose the n value in something. And we cannot use double quotes because those would end the select attribute in the style sheet, so we use single quotes for that. So this is quite typical that the outer quotes are double quotes and the inner quotes are single quotes. Right, so when we apply our first template to our sample data catalog, what we get is HTML like this. So it's an HTML document. There are some namespaces defined that are based on the namespaces defined in the style sheet. And there is the meta element here, which is the result of us specifying the output method as HTML and the encoding as UTF-8, which means that this encoding is also specified in the head. And the rest is purely the work of our template. So in the title element, we have the My Catalog text, which got selected by the XPath expression in the select attribute of the XSL value of element, and the same goes for the heading element in the body. So another thing to note is that the output is indented. White space is normalized, so you may notice that in the style sheet we have the title start tag, then we have a new line and some indentation, then we have the XSL value of element, and again a new line and some indentation, and we end the title element. So for the HTML output, this white space gets normalized as part of the indentation. If the output method was text, all this white space, including the new lines and the indentation in the style sheet, would get outputted as is to the output. So let's extend our template with a second template, and this one will process the data sets. And again, for the data sets, we'll want to output the title of the data set, this time as a level 2 heading. And then we'll want to see the number of distributions of the data set. So we'll use the XPath expression for that. We are currently in the dataset node, so we'll count the descendants filtered to the distribution elements. So all descendant distributions get counted and outputted as a result of the XSL value of element. And when we take a look at the output, there is nothing new. Why is that when we have the new template that should match the data set? Well, the reason is the way XSLT works. And that is that it goes through the input document and goes element by element. When a template matches, that element gets processed by the template. So in our case, it matched the catalog element, which was the root element of the document. And that catalog element got processed by the template that we have just seen. And then the output is outputted, and that's the end of it, because there is no other root element in the input, and therefore the XSLT transformation is finished by that. So the dataset template actually never got to be used. So we need to do something about that. We need to specify that at some place in the output we want to process the other templates. And we do that by inserting the XSL apply templates element in the place of the output where we want the other templates to be applied. So what happens now is seen in the right hand side of the slide. We actually created what we wanted. There are the level 2 headings with the titles of the datasets, and then there are the paragraphs with the numbers of distributions. So this part is okay, but what is weird is that after the first heading of the catalog, there is some text that we didn't expect, right? There is again the titles of the catalogs, then titles or names of the contact point, and the email address of the contact point, and that we didn't expect. So why is that? What is it doing there? The answer lies in a so-called implicit templates. So even if you do not specify any template in your style sheet, the XSLT processor still runs some, and those implicit templates are now displayed in the slide. So even if you do not specify anything, these templates are always there. And they result in all text in elements and attributes to be outputted as is. So that is what we have seen in the result before. So the first implicit template actually matches the root and all elements. So every element or root, so the XPath query in the match attribute is the asterisk, which matches all elements, or the pipe means or, and then the slash, which matches the root element. And all it does is that it applies other templates. Now, the apply templates, when nothing else is specified, it gets the children of the current nodes and applies all the templates specified in the style sheet to those children of the current node. So this causes the XSLT processor to actually go through all the elements of the input document. The second template, the second implicit template, says that it matches all text and all attributes. And when it comes across a text and attribute, it selects and dot is the shortcut for node for self access and node access function, which in case of text or attribute results in the actual text or the content of the attribute. So this template is responsible for actually outputting the text that we have seen before. The first template is responsible for going through each element in the input document. And the third implicit template doesn't need to concern us, but it is there. It actually matches all processing instructions and all comments in the input XML document and does nothing. So it's an empty element, so it does nothing. Right. So what to do if we do not want those implicit templates to be applied? Well, we need to override them. And we will override the one which matches the text because we do not want our text to be outputted, and we override it with an empty template. And therefore, whenever the XSLT processor encounters a text node, it will do nothing. And therefore, our HTML starts looking as it should look like. So we have our catalog as heading 1, and then as heading 2, we have our datasets, and then for each dataset, we have the number of distributions and nothing more. We do not want to override the first implicit template because that one is responsible for the processor to go from the catalog to the datasets element and from the datasets element to the individual dataset elements, which get matched by our second template. So that one we want to keep in place. Now, when we call the apply template function of the XSLT, we may also supply a select attribute, which again contains an XPath expression, which selects the set of nodes to which the XSLT processor will go and which it will start processing next. So by default, it goes to all children nodes of the current element or the current node set. But we may also be more specific, and since we know that there is nothing to process in the datasets element, we may direct the XSLT transformations to directly to the dataset elements like this. So this is the natural way the XSLT transformations go. The natural way is that you let the XSLT processor go element by element through the input document, and you match some of those elements, and you maybe say that some of those elements do not have to be processed, and you direct the processor a little bit, but this natural walkthrough through the input document is what XSLT is built for. However, there is also a different way you can go about the XSLT transformation. So far, the templates were so-called unnamed. So they matched the elements as they came from the XSLT processor. But you can approach your XSLT transformation in a more directive way, and you may use so-called named templates and their parameters. A named template is a template that doesn't have a match attribute, but it has a name attribute. You name your template and then you call it explicitly. You do not leave it to the XSLT processor to match that template, but you call it explicitly. So in our example to the left, there is a new template in the bottom, which is called process title. And this template takes two parameters, an element which specifies or which will specify the name of the element in which the title should be outputted, and the lang parameter, which will specify the language of the title to be used. Right, and this template will cause the element from the element parameter to be created, and its value will be the value of the title in the specified language. And since this template doesn't have a match attribute, it never gets called or matched naturally. You need to call it explicitly. And for that, you use the call template construct, where you specify the name of the template in this case, and we are in the upper half of the example. We will call this template to process title in processing the head, where we will say that our title will be in Czech and it will be the title element. Then for the second time we will call this template in the body element, and here we will specify that the output should be the H1 element and the language should be in English. And then again we'll call this template from within the dataset template, where we'll specify that the output title should be H2 and in English. So like this, you may call a named template. Calling a named template doesn't change the current node or the current node set in which the XSLT processor works. When we are in the catalog element, first time we call the template, when the template is called, it is still in the catalog element, which gets used then when it refers to the title with the XPath expression. A new piece of syntax here is the variable syntax, where whenever we use a variable in an XPath expression, we use the $ and the name of the variable. And whenever we want to use a variable in attributes which do not expect an XPath expression, we enclose the $ variable in curly braces, which you can see in the XSL element example in the lower part of the slide. Now another construct that is quite useful are global variables. So you can create your variable using the XSL variable XML element, and you name it with the name attribute, and the content of that element gets to be the content of the variable. And you can then use the variable, as we have seen in the previous slide, using the $ and name of the variable notation. And if you define this variable in the XSL style sheet element, the variable is global and you can access it from the whole style sheet. You might also want to sometimes create a variable which is local in a template, for instance. In our example, we define the language variable in which we store the language that will be used for the titles throughout the style sheet, and whenever a template actually tests for a language, it uses this lang variable. This means that if we want to switch our HTML to Czech, for instance, we only need to change this content of this variable, and the whole style sheet gets to generating the Czech HTML. Another construct I want to tell you about is called modes. Modes allow us to match the same elements but process them in different ways. Basically, it means that we may have multiple unnamed templates that match the same element, let's say, or the same node, but each of them processes the node in a different way, and the mode is the way of specifying the mode in which the XSLT processor runs currently. So the mode is specified whenever apply templates is called. So in the upper half of the example, you may see that in the HTML head, we apply templates in the mode head, and then in the body, we apply templates again, but this time in the mode catalog. And then we have a dataset template that matches in the head mode, and we have another dataset template which matches in the catalog mode. So in the head mode, the template is empty because we do not want to output any information about datasets when we are when we are generating the HTML head. But when we are in the dataset node in the catalog mode, we want to, for instance, output the number of distributions. And this way, we also have a template matching a title in the head mode and a title in the catalog mode. In the head mode, we output the title element, and in the catalog mode, we output the H1 element. Actually, this is not the whole style sheet. Then I have a template again for title in the dataset mode, which gets set in the template processing a dataset in the catalog mode and resets the mode to dataset. And there I would output the title in the H2 element. So like this, I have rewritten the style sheet to produce the same, but using the modes construction. And if you ever need a template to match in all modes, there is the special syntax you can see at the very bottom of the slide, and that's the #all. One more construct that we can see here is the if construct. So in XSLT, you may use XSLIf, where in the test attribute you have an XPath expression, and if it evaluates to true, for instance here we test whether a language matches what is in the lang variable, the content of the if element gets processed, and if the test doesn't evaluate to true, the content of the if element gets ignored. So like this, you may output conditional things. Right, so this was an overview of XSLT, and there are some features which we didn't see. For instance, there is a switch construct so that you don't have to have a series of if tests. It uses the XSL choose, XSL when, and XSL otherwise elements. There is a for each construct where you can go in an iterative way through a node set selected by an XPath expression and do something. XSLT style sheets can also be split into modules and included and imported into each other. There is a difference because if you use include, then the included style sheet gets included as XML basically. So the processor doesn't look at the content at this time and just takes the XSL file and replaces this XSL include element with the contents of the style sheet element of the other file. Whereas import has a slightly different function. It does the same thing. However, the imported templates have lower priority than the templates in the importing style sheet, which means that if you have templates named in the same using the same name in the imported style sheet and here, then the imported templates get overridden. So those are some remaining XSLT 1.0 features, and from XSLT 2.0, this is a selection of features that might interest you. For instance, if you were to output something grouped by a value of an attribute or an element. For instance, here we have a list of cities on the input and we want to output them grouped by a country. And there is a for each group construction for that. If we want to output to multiple documents, there is the XSL result document, which generates another output, and the content of the XSL result document actually gets outputted to another file. There is support for regular expressions. So if you want to transform texts, for instance, here we transform from one date representation to another, there is a support for that in XSLT 2.0. And if you are interested in XSLT 3.0, which is the newest specification, there is support for streaming. So XSLT 2.0 still loads the entire input document into memory and then processes the templates. Whereas in 3.0, you may switch to streaming fashion, in which, of course, you have a limited selection of things you can iterate through using XPath because of the streaming nature of processing. There is also support for higher order functions, which means that you may create a function and store it as a value of a variable and then call that function from within an XPath expression. And there is also support for text processing. So, for instance, you are able to process CSV files or JSON files using XSLT 3.0 as if it was XML after some transformation, which is implemented by some XPath 3.1 functions, which are used in XSLT 3.0. And before we finish with XSLT, let me just show you some examples. First example of a usage of XSLT can be the IANA registry of media types. So if you go to this file and note the XML extension in your web browser, you will see a regular HTML page. And how is this possible? Well, if we take a look at the source of the XML file, it is a regular XML file. However, if you take a look at the processing instructions at the beginning of the file, there is the XML style sheet processing instruction, which points to the media types XSL file. And your web browser sees this and applies the XSL transformation. And the result of this transformation is an HTML document, which is what you actually see in the browser when you go to this document. So this is one use case of XSLT. It's quite an old one. So you could publish your content in XML so that it's machine readable, and then you generate the HTML representation out of it just using an XSLT style sheet. But otherwise, XSLT is used almost every time you want to process an XML document and transform it to another text document. There is an alternative, which is the XQuery language, which we didn't go to in this lecture. So if you are interested in alternatives, XQuery is one of those. Another example of an XSLT transformation here allows us to actually generate an RDF turtle file out of the input XML file. So here we again work with the same data catalog, but our template matching the root catalog element generates the prefixes and then generates the turtle document that you can see in the right hand side of the slide, which is a valid DCAT representation of the data catalog. Some noteworthy parts of this template are the usage of global variables, which we have talked about, the usage of a concat function, which concatenates two strings. So this is used for creation of the IRIs that identify the catalog and the individual datasets. And also noteworthy is where the IRI of the datasets comes from, because if you take a look at the input document, there are no identifiers that could be used well for creating IRIs for the dataset. So the IRIs are created by concatenating a common prefix with the position of the dataset element in the XML document. So the XML element position can be used to generate a distinguishing ID to be used in IRIs. Of course, when the order of the dataset would change in the input, then the IRIs of the datasets would change in the output, which is definitely a downside to generating IRIs like this. Right, so this was a brief introduction to XSLT. If you want some sources about XSLT and XML in general, there is this collection of texts by Jiří Kosek, which I recommend.